Right, so here's our classic situation. Calculate the length of VM. VM is the midpoint down, the midpoint of the square base. So it's the midpoint of this thing here. We're going to come down, hit the middle, and then bounce into the centre of that circle. Now, one nice thing to remember is the length from the midpoint to the centre, not the centre of the circle, centre of the square base pyramid. That distance there is the same as that distance there. So inside that triangle that I'm going to use, I cannot, because that length is 5, this length here must be 5. You see, so I've identified the triangle that I'm going to use to solve that problem with the line coming straight down the sloping face there, coming into the centre of the circle. Now, what information did they give me? Square base of length 10. Edges, now, edges of length 13 centimetres. So the edges would be, well, they've actually marked it for me there, right? That's sometimes called, they sometimes also call that the sloping edge. So be familiar with that type of language, right? So it's sometimes called the sloping edge. So I've looked at the diagram and I've identified the triangle I'm going to use. So in your solutions, as I say, best thing to do is to actually make a 2D sketch of what you're doing, like this. It also helps to include any letters that they've given you in the triangle. So that's V, we've got M here. Now, as I've said, that's the centre of the square-based pyramid. This distance down here is the same as half. It's this one here. It's the same as half the edge. So I know that that's 5. Is there anything else I can use here to calculate the length of VM? Did they tell us the height or anything like that? No, they haven't.
Yeah, they did. You mean from V to the midpoint?
Let's see the information they give us again.
I saw more.
Now, okay, so this is interesting because look at the triangle. Now, I'm doing this question as I think about it. So look at the triangle I've used. Now look at this. This is me in my exam situation. I've drawn that triangle. I've changed it to this situation here, and the problem is if I've got to calculate the length of VM, which is this length down here, this is missing. I don't know the height of the pyramid, and in fact what I do is I go back to the question and I see that that's what I'm going to be asked to calculate next. So this triangle that I've identified actually doesn't work. So what I've got to do is I go back in and look at the information that I've been given in the question. So I go back to my question paper. Now I already know that that length in there is 5, but this is the target. I need to find the length of this line that comes down on the slope. Now there's actually another right-angled triangle in there that you can use. And if I go, remember that this line is the midpoint. It means it cuts this exactly in half. And there's a special property of a line that comes down and cuts another line in half. And that is that it makes a right angle here, actually on the face. So what I can do is, I can use this sloping edge, this edge here, and now I've got another triangle that's actually lying on the face of the pyramid. So that's the one that I need to use to do the problem. So I'm in the exams, I'm in a hurry, so I'm just going to scribble over that, and I'm going to draw my new triangle and my working down here. Right, so a bit of a panic, but I've managed to recover M, C, and V. Okay, that's 5 now. That's 13. Remember that 13 is the sloping edge on here. And if I can calculate that line there, I've got the answer. So I'm going to call that line, I'm just going to call it X for some reason. Now, because it's a right angled triangle and I'm using the hypotenuse, right, so I know Pythagoras' theorem. I know that if I want to calculate this missing length X, it's the square root, but because you're using the hypotenuse, what are you going to have to do? Yeah, it's a subtraction problem, so it's going to be the hypotenuse minus this other shorter side here. Now, another thing that I'm going to watch out for when I do this, well, I might get an exact answer here, is that when I use my calculator to do this, I've got to be very careful see, is that the square root button there? Sometimes it's hard to read. Yes, it is. I'm going to have to be very careful that I round off properly in these questions. Remember that these are the kind of questions where, okay, I'll just put 25, which is minus 25, which is 5 squared. But it gives me an exact answer, so nice. I don't need to round off. It's a 2-mark question, but it had a bit of a twist in it because I wasn't using the triangle that I was expecting to use, but I still get an exact answer. What is it I need to avoid here?
The unit penalty.
Okay, so let's put the units in. Sometimes they'll do questions with no units, but it's pretty rare. Here they've given you centimetres, so there we go, we stay safe. We're not going to get a unit penalty, and we've got 2 marks there. The 2 marks with a slight difference because this one here, you can see you're using that triangle for a change. More often than not, you're using the red triangle in these questions. But interestingly, in question B now, calculate the vertical height. Well, if I take the blue triangle the way that we've been using, you can see what happens now is you shift your focus to the red triangle on the inside. Because now I know that this length here is 12. 12 centimetres, we've just calculated it. I know that this distance is 5, and there's my next right angle triangle. So let's go back to our answer paper. And for question B then, we're using the red triangle. I might as well use the colours since I've got them here anyway. Coming down, that's the centre of the square-based pyramid, out to the face. We've already calculated that that was 12, this is 5. Pythagoras' theorem now this time, to calculate this height, again, we're given the hypotenuse. So if you're given the hypotenuse, you subtract the other shorter side. And let's see what happens this time. So pull up the calculator. Okay, so square root 12 squared is, anyone? Oh, it's not often I get a studies class. You can all give me the same answer. Right, so there we go. Let's see what happens. Excellent. Now we've got a good example. Right, we've avoided the unit penalty. Now, in this question, their other favourite thing to catch out on is the rounding penalty, the accuracy penalty. So you've got a big long number. You've got to chop it off so that you've got, let's chop it off in a better way. You're going to chop it off so that you get 3 figures in your answer. The first 3 figures, 1, 2, 3. Then now that number's a 0 there. So when we chop it off, that 9 stays the same. I've rounded off, and again, as I said in the last recording, don't forget approximately equal to, although they won't deduct any marks for that, it's just to think of for your studies projects. Rounded off to 3 significant figures, and I've put in centimetres. There we go. Right. Another 2 marks. Now, without even looking at the questions, we all know what's coming next, don't we? What is it we're going to be having to find? So let's just see. Calculate the angle. Calculate the angles. Oh, you can see it. Where are we? Calculate the angle between a sloping face and the pyramid in space. Now, I've taken the triangles away because I want to emphasise for you again. It's one of the favourite questions. The angle that this sloping, let's just shade it in on the diagram. The angle that the sloping face makes, the only way to get that angle is to get the line that comes down and hits this midpoint and then bounces in to make that green right angle. To make that triangle inside there. So you've got the red face, and then behind it, you've got this green triangle that's going into the centre. And it's that green triangle I'm going to use, because on that green triangle, that's the inside angle. Right, it's hiding behind the red face. So it's actually the same triangle that I've just used for this question B. So if you wanted to save time, you could simply mark on this diagram that that's the angle you want to find. And I could use the height that I've worked out, or I could just use the 5 and the 12 that I've already been using. So I could look at these things, you know, and let's say that I'm in exam mode, so I'm not even trying to write things down from memory. This is my opposite, because that's the angle, oh, not the opposite, that's the opposite there. The angle looks at the opposite side, so this is the adjacent, and the big long one is the hypotenuse opposite the right angle. I've got adjacent and hypotenuse, so I could use the cosine here. So I could say cosine theta equals, so cosine theta equals, the adjacent was it 5, yeah? So 5's on the top, hypotenuse was 12. Let's just check, it was 12, wasn't it?
Yeah.
Yes, it was. So, now again, watch out for how you write your maths. Right? You're all capable of writing things like this. That's the working, it's the same as you're going to do in your calculator. Now, I'm pretty sure I'm going to round off here. Tell me the things that I need to watch out for.
Unit penalty.
Okay, anything else? Yeah.
Inverse
Yeah, oh, so you've got all these things to watch out for. So simply, I would have done this at the beginning. I would have gone to my calculator, gone to press that mode button, got the degrees, so that's me set up. Okay, so now let's go back to the question. I want to do inverse cosine 15.
Which is 5.
Oh yeah, okay. 5 divided by 12. In this case, I don't need to close the brackets, but I tend to just do it out of habit anyway. So it's that it actually looks the way that I've got it written in my working there. You can the way it looks in your calculator. So again, we've got to watch out for our accuracy penalty. It's 3 significant figures. So we're taking the first 3 figures, we're cutting it off there. Right, so we've got a 7. So our final answer is 65.4. Now, as you go through school, you tend to get used to being a bit lazy with some things. What you've got to realise now is if you've done all that working and you write down the answer 65.3 degrees, right, you've just not bothered rounding it off properly, or you write down 65.37. You've got to realise that at the level you're working at now, at the end of grade 12, you're looking at losing a mark in that situation. So I want you to focus on it, especially in these questions here. Okay? So 3 significant figures. I've put in my units, and there you go. That's a full question. Working with a triangle, a bit different because we use a slightly different triangle. But you can see there you've got the red face, the green triangle on the inside, and in this case we also used the triangle going in that direction there, right? A blue one.
When we write it out, so when you put 3 aside afterwards, do we have to write that every time?
I would get into the habit of doing it because when you do your project, then it becomes automatic. It's not a big deal because in the sense you've done it, it's in your head anyway because you've done it.
But if we forget to leave it.
In the exam, no, you won't get any marks taken off for that. That'll be fine. But in your maths studies project, it's the kind of thing you'd expect to see.